Hello everyone. Topic of today's video is successive differentiation. What is successive differentiation? It is the process of differentiating a given function in succession or in order or back to back. The result of such differentiation is called successive derivative. That means suppose we have a function y which is taken to be a function of variable x. That means y depends on the values of x. Here y is dependent and x is independent variable. And if I have to find the successive differentiation, that means I have to differentiate this function back to back. And the derivative is denoted by dy by dx. That means derivative of y with respect to x, or we can denote it by f dash x. This is first order derivative of this function. We can use the notation y1 also to denote the first order derivative of this function with respect to x. So there are various ways how we can denote the derivatives of given function. Here dy by dx, f dash x or y1 all represent the first order derivative of this function. Similarly, the derivative of this first order derivative, which is denoted by d2y by dx2 or f double dash x or y2. All these are used to denote the second order derivative of the function y, or we can say that this is the first order derivative of the dy by dx. Alright, so all these are the second order derivative of the given function. That means again differentiating first order derivative, we are getting the second order derivative. Continue this process, we get third, fourth, fifth and other higher order derivatives, which may be denoted by f triple dash x, f 4 times fourth order derivative of x, so on, f n x. Here n means the order of the derivative, or we can use the notation d3y by dx3, d4y by dx4 and so on, dny by dxn. All these represent the nth order derivative, third, fourth and nth order derivative of function y, where y is dependent variable and x is independent variable. N means the order of derivative, and d by dx, d2y by dx2, all these are differential coefficients. Or we can use y3, y4, so on, yn to denote the third, fourth and nth order derivative respectively. Now let's see nth order derivative of some standard functions. Suppose we have a function y is equal to e raised to power ax. If I have to find first order derivative of y, I may write it as dy by dx, and I have to differentiate this exponential function once, which is equal to e raised to power x. Again derivative of a raised ax gives you a. If I differentiate it again, I get second order derivative of y, which will be a e raised to power x, where a is coefficient. Derivative of e raised to power ax is e raised to power ax, and again derivative of ax gives you a. Similarly, I can write it as a square e raised to power ax. Similarly, third order derivative will be equal to a raised to power 3 e raised to power ax. If I have to generalize, we get nth order derivative, and if you see the pattern, in first order derivative power of a is 1, in second order derivative power of a is 2, third order derivative power of a is 3, and in nth order derivative power of a will be n and e raised to power ax, of course. So this is a general result. We can use it further in solving questions, that when we have a function, exponential function e raised to power ax, then its nth order derivative will be e raised to power ax and nth power of the coefficient e. Let's do one more standard function. Y is equal to ax plus b raised to power m. If I have to find first order derivative dy by dx, then the rule is m into ax plus b raised to power m minus 1, again derivative of ax plus b, which is equal to m into ax plus b raised to power m minus 1. Derivative of x is 1, a is coefficient and b is constant, so its derivative will be 0. So what I have obtained, that is m ax plus b raised to power m minus 1. In order to get second order derivative of y, I will differentiate again both sides with respect to x. Because x is the independent variable. So again differentiating first order derivative, I will get second order derivative. And again we will apply the same rule here. M and a is our coefficients. So m minus 1 into ax plus b raised to power m minus 2. And again derivative of ax plus b will give you a. So what is the answer? That means second order derivative is m a square into m minus 1 into ax plus b raised to power m minus 2. Let's find one more derivative of third order before generalizing. So that will be m minus 1, m minus 2. If I write a square over here, then ax plus b raised to power m minus 3, and again derivative of this will give you a. So what is that? A cube m minus 1, m minus 2, ax plus b raised to power m minus 3. Now we are pretty good to generalize. Let's generalize to get nth order derivative. Let's see the pattern. While in first order derivative we had first 1 power of a. In second order derivative it was a square. In third order derivative we have a cube. And in nth order derivative, of course, power of a will be n. Let's observe further. In first order derivative we have 1 factor m. In second order derivative we have 2 factors m minus 1. In third order derivative we have 3 factors. Those are m minus 1 and m minus 2. In nth order derivative we will be having n factors, which are m minus 1, m minus 2 m minus 3, m minus 4, and it will end where? M minus, see, in third order derivative, the last number which was being subtracted from m was 2. So in second order derivative, it is 1. That means 1 less than 2. Here it is 2, which is 1 less than 3. So in nth order derivative, the last number which will be subtracted from m will be 1 less than n, that is n minus 1. And ax plus b raised to power m minus, because in third order derivative it was m minus 3, in second order derivative it was m minus 2. So in nth order derivative it will be m minus n. So we can rewrite it like this, that nth order derivative of y, or nth order derivative of ax plus b raised to power m is equal to e raised to power n m into m minus 1 up to m minus n plus 1 into ax plus b raised to power m minus n. So this is true if m is greater than n. What does this mean? M is greater than m means that the degree of the function given to us, degree of the linear function, is greater than the order of highest derivative. Okay, that means if we have ax plus b raised to power 7, okay, if for example m is 7, then the order of the derivative is less than the degree of this linear function. Okay, so this result is true if this m is greater than this n. What if m is less than n? What if m is less than n? Then the nth order derivative of this linear function will be 0. For example, if degree of ax plus b is 6, then 7th order derivative of this function will be 0. Okay, if order of derivative n is greater than the degree of this linear function, I say that if it is 7, if n is 7 or 8 or 9, then the derivative of this function will be 0. So this derivative, nth order derivative of this function, is equal to m minus 1 up to m minus n plus 1 ax plus b raised to power m minus n if m is greater than n, and if m is less than n, then it is 0. I'm sure all